All right, class. This is going to be your first part of the pre-lab on the Beer's Law experiment, which is quantitative spectroscopy. So this is the spectrometer. We have pretty decent spectrometers actually on campus. I've had students in the past, reach out to me, just tell me about their progress and say, yeah, we did that same exact lab on the same exact instrument. So not only are you getting collegiate level experience of what chemistry looks like, but this is also very true to form to how this type of spectroscopy is done in industry. So I'm going to walk you through this. You need to watch both parts of the video, this one and the workup on the data, and then complete the pre-lab quiz. And you can't start the lab until you've done that, because otherwise you're just entering the lab essentially not knowledgeable enough to really gain a full understanding of it. And instead of explaining this individually to 5 different groups, I've decided to record it this year, give you a chance to take your time through it, pause it, rewind, and it's much more personal experience and differentiated that way. All right, so here's the spectrometer, a couple things about it. This is how you set the wavelength. So we said different types of substances interact with different types of light differently, right? So not all solutions absorb light in the 680 range, namely water, right? So water doesn't absorb light in the visible range, right? We've talked about this extensively. Like, the reason why water doesn't have a visible color is because it transmits all visible photons. But it is useful for the beginning of this lab, because the first thing we're going to do is blank it. So this is the cuvette. This cuvette is 1 centimeter in length, which I will show you really quickly here. Which will make more sense when you watch the second video, but again, 1 centimeter. Okay, pretty typical for a Beer's Law experiment. Right. This is the it's a container where this cuvette goes. Right, it's very important when you run samples and spectrometers of this variety that you wipe off the edge of the cuvette. And we'll talk about that more in post-lab, but fingerprints on the cuvette are ultimately going to introduce experimental error. So, before you enter it, a quick wipe with the chem wipe goes in here. This white square goes right on this line here, because the light is coming in from this direction and the detector is over here, right? So if you put this white square there, it's actually going to block out some of the light, and that's obviously an experimental issue, right? So you push this down. Please do not spill liquid in the holding vessel for the cuvette, and then you shut it. Okay, first step here is to blank it. We're going to hit 0. It says it's blanking. It doesn't take very long, but that is zeroing the instrument. That is analogous to zeroing a balance, right? And it's reading the water at 100% T, as it should, right? That water is not absorbing visible light, therefore we set its transmittance value to %T. So the concept is there's like a light source coming from over here. It's shining a particular type of photon through the material, specifically at 680 nanometer, and then there's a detector over here picking up how many of those photons actually make their way through the solution, right? And we've set the instrument to read 100% T, like I just said, because all light is transmitted in the sample, all right? So you can place your cuvette over here. One of the first steps in this one is going to be to make some dilutions, right? So we're going to create your calibration curve and your calibration standards here by diluting this solution in half in each successive dilution. So you can start with the 0.4. This indeed is your first standard solution. And then I'm going to dilute this one 1 to 10, 1 and 1 in this test tube, like so. So I'm going to take my volumetric pipette, measure to the meniscus exactly. This goes into a test tube. Okay, I'm going to dilute that in half by adding to it 10 ml of water, which I'll grab. Doesn't matter whether it's tap or distilled. Our water doesn't have a color, thankfully. So distilled, non-distilled, doesn't matter. Okay, I'm gonna take now 10 ml of this. Struggling a little bit to get that meniscus. Really struggling. Okay. 10 ml of that solution goes into that test tube. So you've now just cut that solution's concentration in half. Okay. You want to make sure this one is nice and mixed up. Okay. So you now have two of your calibration standards. Okay. You have the most concentrated 0.4. This one is now 0.2 molar. And again, mix it up with a disposable pipette. Don't mix it with the volumetric. Okay. But then the concept is this. The concept is this. You're gonna take this solution here and do the same exact dilution. You're gonna pull 10 milliliters out of this one. Okay. Into the next test tube and repeat. So at the end of the dilution scheme, you should have 5 solutions, and they should kind of look like this over here. They should get progressively lighter. This one is 0.4, this one is 0.2, this one's 0.1, this is 0.05, and this one is 0.025, like that. When you go to start making your calibration standards, okay, you get the water out of your blank, and you fill it with a test solution, which you should start with the 0.4. So take your cuvette, fill it up, wipe it with the chem wipe. It goes into the reader, and you make a measurement on it. You document the absorbance only. Okay. Once you've documented the absorbance in all of your 5 standard solutions, make the calibration curve. But before you do any of that, certainly watch the other video that is part of the pre-lab and take the quiz. That's pretty much it. Good luck.